Now, let us consider this problem. For a reaction, A plus B gives product. The rate log is given by R is equal to K into A power 1 by 2 into B square. So that square bracket represents the concentration in molarity. So, what is the order of the reaction? It's very simple. What we are supposed to do, you just take the power of the terms associated, that is the concentration term of the reactants associated. Okay, then you just add it. So, this is 1 by 2, this is 2. So 2 plus 1 by 2, 2.5, that is 2.5. So that is declared as the rate of the, order of the reaction. So do you understand? So what is order of the reaction? How do you define the order of the reaction? The order of the reaction can be defined as sum of powers of concentration terms of the rate equation. Are you able to understand? Concentration terms of what? Concentration terms of the reactants that involve in the rate of the reaction. That is very, very important. You cannot say simply that is concentration of the reactant. The concentration of the reactant that involves in the rate of the reaction or the speed of the reaction or changes the rate of the reaction. So likewise you have to mention. Okay, and what is the rate equation? The rate R represents rate here. So the rate is equal to K into A power 1 by 2 into B power 2. So A plus B gives a product means, so in such a way that is 50% of the concentration of A is involved in determining the rate of the reaction. Do you understand the meaning? And similarly, 2 moles of B that involves in the rate of the reaction. So they combine together, that forms the order of the reaction. Do you understand this? Right. Then, so that is why we have put 2.5, that is 2.5 is the order of the reaction. Let us go to the next one. So you just look at this. Here it is HrO4 minus, that is bichromate anion. So the 2 moles of bichromate anion plus 6I plus 14H plus, that gives 2Cr3 plus 3I2 plus 8H2O. Now let us look at this problem. So here you have got the bi, so whenever H is there you can say bi. For instance, a carbonate. What is carbonate anion? CO3 minus. If it is the HCO3 minus, then it is called HCO3 is bicarbonate. CO3 2 minus, that is carbonate. HCO3 single minus, monovalent, that is bicarbonate. So similarly, CrO4 actually 2 minus. You know very well, that is dichromate, chromate. Okay. Potassium chromate, what is the formula? K2CrO4. Potassium dichromate, what is the formula? K2Cr2O7. Now, what is this? This is bichromate. Do you understand? It means, can you get me the formula of potassium bichromate? So, potassium bichromate is nothing but KHCrO4. That's all. Why? Because HCrO4 minus is a monovalent, whereas K is plus, K plus. So they can be combined. So you can call it potassium bichromate. So KHCrO4. So I hope now you should be able to understand this. So it is an anion. Then you have got another anion, that is iodide anion. 6 moles of anion. And then 14 moles of H plus. You just look at this. What is the molecularity of this reaction? Can anyone say? The molecularity of the reaction is nothing but you have to add all the moles of the reactants. So 2 plus 6 plus 14. It means 22 is the molecularity. Do you understand? Now let us check it out. What is the order of the reaction? The order of the reaction need not be 14 plus 6 plus 2. Do you agree with me? It is not 14 plus 6, 20 plus 2, 22. It is not 22. So on what basis we have to determine the order of the reaction? We have to decide based on the rate equation. What is that rate equation? We have got here R is equal to K into HCrO4 minus into I minus whole square into H plus whole square. I hope now you should be able to understand, even though there are chromate, bichromate anion, it involves only one. Do you understand this meaning? Okay, I hope now you should be able to differentiate between molecularity and the order, because in this case, even though there are two bichromate, only one bichromate is involving in the rate of the reaction. Even though there are six iodide anions, here only two anions are representing the rate of the reaction, and there are 14 H plus, and here only 2 H plus, that is, are involving the rate of the reaction. So in that case, what is the order of the reaction? Now this is the, and you may ask me, sir, how did you get this equation? This is obtained from the experimental factor only. As I already mentioned, you cannot simply get the order of the reaction just by looking at the given equation. By just looking at the given equation, you can find out the molecularity, but definitely not the order. So order can be expressed or found out only from the experiment. Do you understand this? Right. So R is equal to now K into, what is K? Rate constant. So HClO4 minus into I minus whole square, then H plus whole square. The square bracket, that represents what? That represents the concentration in molarity. Do you understand? Right. So the order is, in this case, 1 plus 2 plus 2, that is 5. Do you understand? Whereas molecularity is 22. I hope now you should be able to understand the difference between the order and the molecularity, and how to determine the order based on the given rate equation. Do you understand this?